So let me summarize the lessons that we have learned. So basically we learned about why software engineering is important and what is software development life cycle and what are the steps in software development life cycle and why it is critical and required to engineer a software. And then we have learned about designing tool, so which is Flowchart, and also learned about uh, pseudocodes. Actually, today what we are going to do is we are going to convert that pseudocode and flowchart to actual programming code, and that is today's task, right? So those who have not there, those who are not there in the class, let me go through the note again, and I'll share this note with you anyway. Don't worry, I'll share the note with you. Let me go to the beginning of this note. And first of all, we discuss why software is important, because it works with information and data. Information is one of the most valuable economic resource. It is one of the most valuable economic resources, and that's why software should be engineered. Because so if we use software in environment where information is critical, for an example, if you use software in a flight or a ship or a vehicle, it is life critical. And if you are using this in government or military, it will affect entire country and the security. And if it is used in research center, let's say software is used in this COVID-19 uh, injection releasing thing, so it is then it affects entire world. If it calculate, if it gives some wrong result, it will affect the entire world. And if it give a correct result, same. So software is very important component. Therefore, software is called very important component. Should be engineered, carefully designed, using these steps in software development life cycle. The careful engineering process is called systems development life cycle or software development life cycle, where you have to identify the problem exactly and find the requirements and design the system, then develop the system, design the system, and after that you have to develop the system, and finally you have to test the system and release it. So problem definition is where you are identifying the problem. So let me give you an example. Problem definition, for an example, assume that you are in ancient era where these ancient human beings were starving, or they were suffering to find food. අපි හිතමු ඒ කාලේ ඔයා දැන් ඉන්නවා කියලා. අපි ඊට කාලේ ඉස්සර මිනිස්සු අර කෑම හොයාගන්න හොයාගෙන යන කාලේ. So they were moving from one place to another place finding food. And what was their problem is basically food. But solution to that problem was moving from one place to another place. That was the solution. You know, if you have read history, you know what they have done. If their problem was food, the solution that they have taken is moving from one place to another place. That is the first era. And then only they found that it is possible to cultivate and find food, and that's they learned later. But initially they were started traveling from one place to another place to find food. That is the requirement. When they were traveling, actually they would have done something like this. So that is called feasibility study. That means they would have searched for some alternatives. Alternative means traveling can be done. So like fishes, so they can swim, or they can fly, or they can jump like monkeys. Likewise, they were thinking about different method, but later I think they decided to walk, because walking is special feature of human being, and they found walking convenient than jumping from tree to tree. So walking is safe and convenient, because jumping from one tree to another tree, just having kids, it's and maybe if this woman they are pregnant or they are not well, jumping from one tree to another tree would not be really good. So walking is the safest way. So likewise, they have to find the safest from different alternatives. It is required to find the best alternative. And after that, after finding the alternative, they have to come with a design, proper design. Design basically planning. That's what we are doing with the pseudocodes and flowcharts. We plan the system, and that's what we are doing using these flowcharts and pseudocodes. We plan the system. Similar to that, ancient human beings, those people, they have planned. They have planned to build a walking path, right? That was the initial plan. So they have to consider about where the obstacles are, where these jungles, and where these poisoned trees and maybe animals are there. Likewise, they have to analyze and find the best, come up with the best design. So convenient path to move from one place to another place. That is their design. And then actually they have to do that. In software development, design is not enough, because when you design a software, it's not enough. Why? You have to come up with the actual software. Then only it's working. Today, what we are going to do is that we have designed, we have tried design, and we have come up with different solutions, flowcharts and pseudocode. Now today we have to implement that. And after implementing, even that ancient people, they could have tested the system before handing over, before deployment. Deployment means handing over. Right? Before handing over, maybe some energetic people have tested the route, because you cannot hand over that directly to your children and women and maybe adults. It's difficult to them to directly walk through the path that those people created. So they could have tested that. They would have tested that, and they would have tested and handed over to the general audience. That's handing over is called deployment. And after that, time to time, they had to maintain that path, because with the rain, some damages were there, might be there. Uh, Likewise, even you can see if you create a walking path, what will happen after some time? So you have to clean that. You have to clean, maintain, do a lot of things. And that is not the end actually. Why this is a cycle? The last C refers this as a cycle. So from top to bottom, if this is going to be top to bottom approach, this will be a sequence. But this is not going to be ended with review and maintenance. After some time, maybe they are children, might think this walking path is not really convenient. We need some wider route, wider road to go with our animals and families. So new problem is need wider road, because current one is very narrow, cannot move with animals. So they could have come up with the second problem. Second problem is more wider. And maybe after some time they might feel that this is not this is not comfortable. The third problem is comfortability. They came with another kind of road, maybe with some metals and all, or they can put stones and maybe level the road likewise, and maybe applying some materials other than soil, maybe sand, and they could have tested that. Likewise, was searching for convenient path. Then that is also not over. After sometimes they might feel this road is this road, it has more traffic. So next they have to come up with a traffic control mechanism, which is even wider road to control the traffic. Likewise, this is never ending. So let me give software based examples. So initially in my school ages, in my schooling time, I learned a software called for operating system. I learned MS-DOS. I have learned MS-DOS, and I've learned another software for actually that is alternative for MS Word. Now MS Word is there. At that time it was Word Perfect 51, WP51, and Excel was Lotus 123. Programming we did with basic 123, Q basic, GW basic. Those were programming languages we learned. But it was not ended. Again, after some time, Microsoft introduced Windows 3.1, which has a graphical user interface. Then Microsoft introduced Windows 95, which was quite good for graphics, but not really good. Then they came up with Windows 98, somewhat good, and we could have played movies and all. We watched movies in Windows 98 actually. So because Windows 95 was not really good for movies, Windows 98 was quite good. Then XP, then then Windows Me, Millennium Edition, then Windows XP, then Windows Vista, Windows 7, Windows 8.1, Windows 8, 8.1, then Windows 10 now. But after 10 years, let's say after 10 years, now you went to university and came back, you are doing a job, maybe you are married. Now you want to teach your child one day after, maybe after 20 years, you want to teach your child about computing. Now Windows 10 will not be available. Windows 10 is now ancient. It is Stone Age application or Stone Age operating system by next 20 years. Because it's going to change. It's going to change. Last year, I went in 2018, I went Bangladesh, and I found that still there are courses for Windows 98 in 2018. Actually, I saw in Sri Lanka, no one was using Windows 98, but in 2018, Bangladesh was using 98, and they had different courses for Windows 98 at that time. So because updating is, it's country to country also, it's different. Country to country also, updating is different. Right, okay. Now we know why this is a cyclic process. Software development life cycle, why? Problem is always new. You have to find out a solution with strategic way, and that is called software development life cycle. After solving the problem, again another problem will happen. That is never ending. So you have to, this is a cycle. In this cycle, we learned about the first design tool, that is Flowchart. The very first designing tool, that is Flowchart. And then we learned how to convert that Flowchart to pseudocode. Pseudocode means not actual code. It's a similar code to actual code, which is not working, but way of writing down the code. It's not true. It's false code. You can write any kind of false information there, but the thing is, it should be logical. So likewise, it should be logical, right? So that's how you write pseudocodes. Okay, so these are the symbols. I think you can remember. So this is for start, and this is for input and output, process, decision, flow control, and connecting. This connector, I said this is optional because some are roundabouts, some are junction without roundabouts. Some junctions are there in roads without roundabouts, but still that is a junction. But some junction you have roundabout as well. Similar to that, connector is optional. If you wish, you can put the connector, but if you wish, you can remove that as well. Okay, then today we are going to convert these problems. So basically in programming, there are 3 ways to solve the problem. Or combination of these, either one method or combination of 2 or more methods. To solve a problem, basically you are using one method or combination of one method or combination of these methods. So these are called, I'm highlighting, these are called control structures. These are called control structures. Okay, there are 3 control structures basically: sequence, selection, repetition. Very important. Remember these 3 words: sequence, selection, repetition. Please remember these, or we call iteration. Okay, let me give examples. Sequence, basically, sequence is where instructions are executed one after the another. In sequence, we execute instructions one after the another, similar to, okay, let's say a real life example. Let's take a real life example. How you came from grade 1 to grade 11 is through sequence. How you came from grade 1 to grade 11 is through sequence. Why? You passed grade 1, then came to grade 2, passed grade 2, then to grade 3, passed grade 3, then to grade 4. Likewise, one after the another, you came to grade 11. Now you are in grade 11. What is selection? Selection, can you give the same example? Can you extend the same example for selection? Can anyone? කාට හරි පුළුවන්ද? දැන් එකේ ඉඳන් 11ට ආපේ පිළිවෙලට. that is sequence. එකේ ඉඳන් 11ට ආවේ පිළිවෙලට sequence. Selection ඒකෙම කියන්න බලන්න. Selection. So I need this class to be interactive, otherwise I will feel sleepy. Anyone? Joel, Ravindu, Anuj, කවුරු හරි කමන්නේ. Yes. Hello. Can you all hear me?
Selecting of subjects.
Yes, selecting of subject, maybe selecting A-level subject. After A-level, what will happen? After A-level, after O-level, yes, after O-level, you select whether to do maths, whether to do science or biology, whether to do maths or science, or whether to do commerce, or whether to do arts, or whether to do technology. You search, you select, you decide. You can't do like this, no? You can't do maths karanawa, maths karna, art karna me par. Next time I'll do biology and commerce. You have to select one subject scheme. That is the way. A flow scheme, but you have to select one alternative. That is called selection. And actually repetition is also common in Sri Lanka. What is repetition? Flow, the logic flow of the instruction is repeated until a condition is satisfied. What is repetition then? So in repetition example, it's unfortunate situation in Sri Lanka. You select wrong subject. You select wrong subject for A-levels. For an example, okay, think since others are doing biology, you also select biology. Where you are good in maths. Or maths or biology. Then you are not very good in remembering things. First time campus and second time campus and third time also you are doing. That is the unfortunate situation of repetition or iteration. You follow the same instructions again and again until a condition satisfied. So that is called repetition. Okay, in programming also you can see all these things. Okay, for an example, giving a color to this word. Giving a color to this word. Is it selection, sequence, or repetition? වචනයක පාට වෙනස් කරනවා. Is it a selection, repetition, or sequence? Yes? You can tell. වචනයක පාට වෙනස් කරන එක selection වලට උදාහරණයක්ද, repetition වලට උදාහරණයක්ද, sequence වලට උදාහරණයක්ද? Sorry?
Sequence.
Sequence means it should happen one after the another. එකකට පස්සේ එකක් වෙන්න ඕන. So it is selection, no? Basically you have set of colors, you have to select one color. Ne? මේ colors ඔක්කොම එකපාර දෙන්න බෑනේ. You can give one at a time. එක වෙලාවක එක color එකයි. If you give blue, that's blue. වචනෙටනේ. වචනෙට පාටක් දෙන එක. If you select yellow, it's yellow. If you select purple, it's purple. So that is one at a time you call selection. You can't give multiple colors at a time. එකම වෙලාවේ colors ගොඩක් දෙන්න බෑ එකපාර. That's selection. Yes. So okay, I'm going to do something like this. I'm going to select letter by letter. I'm going to select letter by letter and moving forward. What is this? I'm selecting letter by letter and moving forward. What is this? Selection, sequence, or repetition? Yes? Yeah, it is repetition. Why? Why it is repetition? Why it is repetition? Because shift එක ඔබනවා මම. It was arrow key එක ඔබනවා. arrow key එක ඔබනවා. Again I'm pressing arrow. Again arrow. Shift එක ඔබාගෙන මම arrow key එක press කරලා මෙහෙම 1 2 3 4 5 6 7 8 9 10. This is repetition. Until this sentence is over, I am repeatedly pressing this arrow until this sentence is over. I'm repeatedly pressing this arrow, which is called repetition. Okay, sequence is something like this. Sequence is maybe you are writing a letter. You are writing a letter by letter, A, B, C, D, E, F, likewise. It's written in singular. So anyway, that is sequence. Sequence is normally, most of the time we can see selections and repetitions. Sequence is nearly uncommon. Sequence is there, but most of the programmers like ගොඩක් වෙලාවට program ලියන්නේ some advanced functionality. So that's why. Otherwise, sequence is there everywhere. But programmers are writing programs for some advanced functionalities. Right? That's why the sequence is rare in programming. Cannot show practically, but most of the time you have. So let's say you have 1, 2, 3. The numbering system, that is sequence. If you apply bullets, that is sequence. Sequence is also there. Okay, let's try small example. And I'm trying to convert this. I'm writing an example. Let's write the same one. I'm going to give you an example. Input 3 numbers and display the total and average. Input 3 numbers and display total and average. Draw a flow chart. Draw a flow chart. Write pseudocode and Pascal code to do the above function. Okay, write down the question and quickly I'll give you, let's give 4 minutes, no, 2 minutes, enough. Quickly draw the flow chart and pseudocode. ඉක්මනට අඳින්න flow chart එකයි pseudocode එක. Input 3 numbers, display total and average. So you know the flow chart symbols, no? Start and end, rounded rectangle or ellipse. Input, output, parallelogram. Process, rectangle. Decision, diamond. Data flow, arrows. And connector, it's circle. Okay, quickly do this. Quickly write, basically draw the flow chart and write the pseudocode quickly. We'll give you 2 minutes. Okay, so you check with this one. හරිද මේ ලියලා තියෙන මේකමද ලියලා තියෙන්නේ? Is there any changes? Changes තියෙනවා නම් අහන්න. Is there
total equal 0 AD කුත් දැම්මා වැඩිපුර.
That's all. වැඩිපුර තිබ්බට නම් කමන්නේ. But thing is, so the most required component should be there, right? So it's okay to add additional thing, but the thing is, so most required components you can't draw. Right? At the start, input n1, n2, n3, then total equal n1 plus n2 plus n3, then print total and average. Okay, print the total. Okay, print the total and average and n. Okay, this is the flow chart. And pseudocode is, it's even simple. Pseudocode එකේ මේ flow chart එකේ තියෙන මේවා ටික ගලවලා නිකම්ම ලිව්වම begin input n2 and n2 to n3 total, then average is well total divided by 3, print total and average, total comma average. That's all. That is your flow chart. Please draw this. මේක කරලා තියනවද නැද්ද? අනිත් අය? රවින්දු? Ravindu, okay. Then Senut.
නෑ සර්.
අදද ජොයින් උනේ Senut නැත්නම්
අද සර්.
අද නම් හරි. කරන විදිය තේරෙනවද Senut නැත්නම් so you are Sinhala in Sinhala medium class or English medium class you want?
English medium.
Can you understand the way that we are doing?
Yes sir.
Okay, if not, please let me know, then I can explain from the beginning, right? If not, please let me know, then I can explain from the beginning. So we are using these symbols, that's all. So we have to write this using these symbols. Okay, start is rounded rectangle or ellipse. End is here also end should be here. This should be end or stop. Both are not start. Then you can't start again. Start, then end should be stop. N1 plus N2 plus N3 total equal N1 plus N2 plus N3 and average equal total divided by 3. Then print this. And same thing you are going to write as pseudocode, nothing else. This is in structured English. This code will not work. මේ code එක වැඩ කරන්නේ නැහැ. Sure එකටම වැඩ කරන්නේ නැහැ. මේ නිකන් ඉංග්‍රීසියෙන් ලියන්න තියෙන්නේ. That's all. Okay. Okay, then now we are going to start the cricket match. We are going to start the game now. Now you have to play with me, right? So because we are going to code, this is serious. So if you are using computer, you can do it using computer, or otherwise you have to do using your mobile phone. Dekin on එකකින් කරන්න පුළුවන්. Ready to do? Finish writing these things? ඉවරද ලියලා? Okay, right. All. Senithu harida, Senuth harida. Joel, Anuja.
ඉවරයි සර්.
හරිනේ. Okay. Okay, let's go. අපි ගිහිල්ලා බලමු. එහෙනම් දැන් ඊළඟට යන්න අපි code එක ලියන තැනට. So let's go and do the code. Google එකට යන්න මගෙත් එක්කම ගිහිල්ලා search කරන්න. Search. Google එකේ search කරන්න. Pascal online compiler කියලා search කරන්න. Pascal online compiler. නැත්නම් online Pascal compiler. හරි search කරාද? phone එකෙත් පුළුවන් ප්‍රශ්නයක් නැහැ. lap එකේ හෝ computer එකෙත් පුළුවන්. ඔගොල්ලෝ උත්තර දුන්නොත් තමයි මට ඉක්මනට කරන්න පුළුවන්. ඔගොල්ලෝ හොයලා ඉවර නම් හොයලා ඉවරයි. හරි වාගත්තා. දැන් මේකට බෑ කියන්න බෑ ඔයගොල්ලන්ට. මොකද you are using either mobile phone or I know that you are using mobile phone or laptop or desktop. එහෙම නැති වෙන ක්‍රමයකට දැන් මේකට සම්බන්ධ වෙන්න විදියක් නැහැ නේ online නේ තියෙන්නේ. So everyone can do this. Finish. Right. Then go to this link, not the first one. First link එක නෙමෙයි ඔයාලගේ වෙනස් වෙන්න පුළුවන්. මේ online GDB කියලා තියෙන්නේ. ඔයගොල්ලන්ගේ සමහරට මේක තියෙන්න පුළුවන් මේ 3 වෙනියට හරි 4 වෙනියට හරි. මගේ නම් තියෙන්නේ උඩම. මම ඒ නිතර යන හින්දා. Online Pascal compiler, online editor කියලා දෙනවා online GDB. This site is onlinegdb.com. Go to that. එක 3 තියෙන්න පුළුවන් 4 තියෙන්න පුළුවන් පල්ලෙහා තියෙන්නත් පුළුවන්. But go for the same link, online GDB, online Pascal compiler. Go to that link. Okay, now hopefully you are in this. So in this curly braces, you can write anything inside this curly braces that is going to be ignored by your Pascal compiler. Hello, this is your first program. You can write anything that will be ignored because it is in between these curly braces. This will be ignored by compiler. What is compiler basically? Can anyone tell me what is compiler? What is compiler? Yes? What is compiler? Compiler is a special program which is going to translate. Okay, if you don't know, you can write down. Right? If you don't know, better write down. Compiler is a special program which is going to translate program code to machine readable binary code or machine readable binary, or we call machine code. It's a translator because earlier days we used to write programs using direct machine language, but nowadays we can't write programming using machine language because it is too complex to write program using machine language. So we are using high level languages. These high level languages machine cannot understand. So we need to translate that high level languages to machine language. It is compulsory. So compiler does that role. There's another one, interpreter. An interpreter similar to the compiler, but translate one statement at a time. This is similar to the compiler, but it translates one statement at a time. Here, this translate all at once. Translate all at once. But interpreter translate one statement at a time or one line at a time. So in Pascal, we are using compiler. In Pascal, we are using compiler. If you don't know, please write down this. මේ අර අපි ටයිම් ලිමිට් එකේ ඉන්න ඉඳලා විනාඩි 40න් ඩිස්කනෙක්ට් වෙනවා. ඒ ලින්ක් එකෙන්ම ජොයින් වෙන්න. Use the same link to join. So immediately මම stop වෙනකොටම මම recording එක දාලා ආපහු join වෙනවා. Please use the same link to join again. තව විනාඩි දෙකක් විතර තියෙනවා disconnect වෙන්න. disconnect වෙනකොටම ඒ link එකෙන්ම ආපහු join වෙන්න. Okay, now you know compiler and interpreter both. Okay, now you know compiler and interpreter. Right? Then Pascal uses a compiler. Okay. The compiler ignore karna. Compiler this comments here. What is important? Comments will be ignored by the compiler and interpreter. Both will ignore comments. So you can write anything here because your compiler and interpreters will. Here Pascal we are using compiler. Right, let's move on. Our first program, I'm going to introduce two variables. I'll explain this code more clearly because this is the first time. I hope you have not done programming earlier. Kalin programming කරලා නැහැ කියලා හිතලා තමයි මම මේ කියලා දෙන්නේ. This is your first time. හරි, එහෙනම් බය වෙන්න එපා. අදම ආවත් ප්‍රශ්නයක් නැහැ. I'm going to add two spaces දෙකක් ගහලා මම ලියනවා n1 කියන්නේ integer එකක්. පූර්ණ සංඛ්‍යාවක්. And again, n2 is also integer. And total is also integer. n1 is integer, n2 is integer, total is also integer. Write the same. ඔයාලට දැන් ඇවිල්ලා ඇති මේ ස්ට්‍රීම් එක මේකෙම මේවා ලියන්න ඕනේ නැහැ. මේව මැකුවත් කමන්නේ. මේ උඩම තියෙන ඔක්කොම ටික මැකුවත් කමන්නේ. No need to write this. So important part is this one, program. Please write this n1 is integer. Integer means so this is I'm declaring මේකත් ලියන්න එපා මේක කමෙන්ට් එකක් නේ. Declaring n1 variable as integer variable. Declaring n1 integer as variable. That is what we are doing here. Declaring n1 as integer variable, declaring n2 as integer variable, and declaring total as integer variable. So please do this quickly. Please do this quickly. And in the beginning, same time, I'm going to assign some values. I'm going to tell that two spaces දෙකක් තියලා ආයෙත් මම ලියනවා. n1 colon equal 10, n2 colon equal 20, and total